Now we want to do problem 19 from the book, and it's titled Snowplow Speed. All right, they're trying to get us ready for winter. So let me read the problem out of the book. At 6 a.m., a snowplow traveling at a constant speed begins to clear a highway leading out of town. At 8 a.m., an automobile begins traveling the highway at a speed of 30 miles per hour and reaches the plow 30 minutes later. Find the speed of the snowplow. All right, so hopefully you see the picture here. Early in the morning, the snowplow begins to clear the highway. So he's plowing for 2 hours. And all of a sudden, some person in their car takes off, and it takes 1/2 an hour, it takes 30 minutes for the car to catch up with the snowplow, because of course the snowplow wasn't going that fast. So they're saying how fast, in fact, is the snowplow going. So once again, I'm going to draw a little bit of a picture. So I'm going to say at 6 a.m., like this is the plow, and it starts going down the highway, and then 2 hours later, at 8 a.m., we have a car that takes off down the road. Now it says the speed or the rate of the car is 30 miles per hour. So this guy is going 30 miles per hour, and he catches up to the snowplow. The car catches the snowplow, SP, in 30 minutes. Now here's one little tricky thing about story problems. You have to make sure your units are consistent. I noticed here when it gave me the speed of the car, it said the speed of the car was 30 miles per hour. And now it gives me this time, and it tells me the time is in 30 minutes. When I start doing the math for this problem, I've got to make sure my units are consistent. What that means is, every time I refer to any kind of time in this problem, I have to have the same units. You notice the units for the speed is in hours, but the actual time that it took the car to catch the plow was in minutes. So before I do anything else, I'm going to actually change this 30 minutes to 1/2 or 0.5 hours. I probably could use 1/2. We'll just have to see maybe which makes the math easier. Now let's think about what's going on. So if that car was going 30 miles per hour and it took 30 minutes to catch the snowplow, how far did that car travel before it caught the snowplow? So the distance the car traveled, once again, over here to the side, I'm going to write the equation we always use for what I call travel problems. The distance you travel, the distance you drive, whatever you're doing, the distance is the rate or the speed times the amount of time you're traveling. So if I'm trying to think about how far the car traveled, I know he was going 30 miles per hour, and he was traveling for 30 minutes or 1/2 hour. So how far did he travel? 30 miles per hour times 0.5 hours. He ended up traveling on the road for 15 miles until he caught the snowplow. So that tells us basically how how much of the highway the snowplow cleared. If I look at my picture, I can now say this distance is like 15 miles. So that's how much of the road the snowplow cleared until the car caught up with him. So now the way we're asking for the speed of the snowplow. Well, once again, if we use our distance equals rate times time, I'm trying to figure out R. So R is D divided by T. So do I know the distance that the snowplow traveled? Yes, I do. I know the snowplow was able to plow 15 miles. So I put 15 miles in for the distance. Do I know how long the snowplow had been plowing? Well, yes I do, because the snowplow started at 6 a.m., the car started at 8 a.m. So the snowplow had a 2-hour head start, and then it took the car 30 minutes to reach the snowplow. So actually, the total time that the plow was working was 2.5 hours. So I know I can put 15 miles over 2.5 miles per hour. So therefore, that should be the speed that the snowplow was working at. So 15 divided by 2.5 looks like the snowplow was going 6 miles an hour. All right, so that's another problem that involves using the distance equals rate times time.